Great seeing you here again. My name is Luc de Kuster, founder of the Kuster Academy. And in this video, I will talk about the principle of activity duration estimation. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Let's have a look at the duration of an activity. How are we going to determine that duration? And it's a very important problem because once we have the network diagram, we want to create a schedule. We want to find out what is the start and the finish time of every activity. And when we know that, we can create a Gantt chart, a schedule baseline, which will be used later when we will start the execution of the project. And we will evaluate progress relative to this schedule. Typically the Gantt chart, but we can also use earned value management parameters. Now we want to know how long is the activity going to take when we will be working on it in the project. And we have to start with different parameters. We have to understand what is the effort of that activity. Mainly, what is the time it will take when one resource will work on that activity. Now we also have to understand what are the resources we need to work on the activity. Once we know let's say the specifications of the activity, we know what type of people and materials we need, and there may be some other factors like experience of the people that we want to use on those activities. Now we typically start from the effort and we add more resources, and when we add more resources we will find the duration of the activity. But be careful, we cannot keep on adding resources, it's limited, which we defined by the principle of the crash point. From some moment, adding more resources may lead to an increase of duration instead of a decrease. Another element we have to take into account are the different activities, the type of activities. We have fixed duration activities, which will always take a certain time, whatever the amount of resources we add to that activity. So we have to be sure that our activity or the duration of the activity is determined by the number of resources that will be allocated to it. When we look at agile approaches, or more adaptive approaches, we may look into different ways of estimation. You may remember in Scrum, when we look at the Fibonacci poker, the Fibonacci estimation, we are looking at the relative complexity, the relative durations of activities, and we're not going to calculate absolute values and absolute duration. We use the Fibonacci series to give a weight to the different activities and determine the number of points of every activity. Based on that, we would be working on those different activities, and we will see how many points we typically can finish during one cycle, for example, one sprint. So there may be different estimation techniques available that we may want to use or will use when we're using or when we're working in an agile environment. Importance of historical information. Well, historical information is very important. Now, the fact that we are creating an organization, we're creating a center of knowledge, we have to see what information we have from previously completed projects. Now, once we have a project that is completed, we have the knowledge, the people and the organization will obtain that knowledge, and we will store that knowledge. And we've spoken before about the organizational process assets. These are in fact all the elements related to knowledge from previous projects, from other information that we have. And the historical information is part of this or these OPAs. Now we can compare activities that we are considering on a specific project with activities that have been completed in the past with similar activities, but we have to be careful because some parameters may have been changed. We may have had new technologies. There may be some other parameter. Comparing is not just copy-pasting. Comparing is basically an intelligent way of evaluating the adaptivity of past activities, their information, and integrate them into new activities that are being used in your new project. There also may be databases that you can find, public databases, and project managers may have similar experiences working on similar projects, so we can find a lot of information also internally but also externally. We also have some methods, typical methods, Delphi method, interviews, and there may be some other methods that you can find. Now, when we don't have any historical information available, it may be difficult to have an idea about the duration of the different activities. And we may find some relief in what we call the Delphi method. And the Delphi method is not only used in project management, it's a widely adapted technique where you bring together a number of subject matter experts. Subject matter experts are people who are, let's say, specialists in the area that you are considering, and you provide them some information about the activities or the work that you want to do, and they will provide you with an estimate. Now, once you're looking at the estimate, is the fact that you will be comparing the estimates given by the different people in the team. And you will challenge each other. You will invite the people who gave you the lowest and the highest estimate to explain why they gave that number. They will explain to you why it's 30 days and somebody may say it's 25 days or 20 days. And then people will make another estimation. And every round, you will see that there is convergence. People are coming closer to a solution. And we did the same thing in the Agile method in Scrum when we talked about Fibonacci poker. We used these elements, also a similar method, to evaluate the effort, the duration of activities. We also may look at other techniques. We can interview different subjects, subject matter experts. We can look at external databases, which are typically publicly available. Another thing we can do when we are estimating is to include uncertainty in the estimation. Now, most estimations at the beginning were done as certain. The time given to finish an activity was considered to be certain. And reality shows us when we look around, it's not a really sure thing. We never know if it's really certain or not. There may be variations, common cause variations, which is completely normal. Now, when we look at experience and statistics, we know that we can have common cause variation, and that's the variation which is obtained even when we do everything the way it should be done. It will never be exactly the same. That's why statistics became important. Now, looking at statistics, the project managers were looking at the typical evaluation of the project. They saw that the project was evolving in a certain way, and typically they identified that the duration or the finances are in fact following a beta distribution. And based on that, they created an estimation technique which we call PERT, and that's where we have the PERT diagrams from. We calculate an expected duration and a standard deviation. Now, the PERT formula on itself led to an estimation when we have the expected duration, for example, is the optimistic A plus 4 times the probable M time plus the pessimistic time divided by 6. It's a weighted average where we give a higher weight to the probable outcome, the mode. And we can also calculate the standard deviation in this case, which is B minus A, the range basically, divided by 6. That's one way to do the calculations, but over the years they also found that in case you're not really sure about the distribution, you have some doubt about this, you can use a different probability function, and that probability function is a triangular function, a probability density function. And in that case, the elements, the calculations, the formulas are a little bit simpler, and we call them the 3-point estimation. So PERT is what I just shown you, the formulas at the left. When we go to 3-point estimation, we do the same, we have the same principle, but now we take the average of the optimistic, pessimistic, and the mode, so we divide by 3, and the standard deviation is again given by B minus A, but now we divide by 5. So in this case, we have duration estimates which take into account probability effects. And it leads to a better result when we look at all the projects, and the experience is really good when we're taking that level of uncertainty into our estimations. So that was it for this video. I hope you liked it. There are a lot of other videos to come. Anyway, before you leave, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you very soon. Bye-bye.